Okay, I'm going to show you how to run ANOVA in Excel. Now, after you see this, you're going to go, this is so easy. Excel is going to do all the work for you. Here's the thing on the test, though. On the test, I'm not going to expect you to run it, mainly because I don't want you messing with data and making sure it's all in right. I'm going to give you the output, and I'm going to ask you to give me a conclusion. So it's important you know how to read the data and the results, as well as know how to do it, because on the tests on the project, some of you might find that doing ANOVA is a very good idea for part 5. So now we have data from car crash experiments and the test values of chest deceleration data for the dummies in the driver's seat. And we're going to test at a 0.05 significance level to test the null hypothesis that the mean weight categories have the same mean. Now in ANOVA, your null hypothesis is always that the means are the same. Your alternative is always that the means are not the same. And on the test, I'm going to expect you to tell me this, so make sure you know this. And do the data suggest large cars are safer? Well, so first we have to run the test. So I'm going to copy the data over here, and I'm going to copy it to Excel. I'm going to hit paste, and here's all my data. No copying required. Now, to run this test, I'm going to go to Data, Data Analysis. If you do not see this, you need to install it. Get out your disks and install it. I'm going to go to ANOVA, Single Factor. Okay, so now my data here, you can see I just did this, A1 to D6, so that's this entire block. I'm in columns. My labels are in the first row. My alpha is 0.05, and I'm going to put the output down here at A15, so it'll go down here. You could put it in a new worksheet, new workbook, whatever you wanted. Okay, so here's my output. This right here is what matters. How did I do that? Okay. This is what matters here, the p-value. This p-value we are looking at, is it less than 0.05? Yes, that is way less than 0.05. So, yes, we can reject the null hypothesis because the p-value is less than significance level. So B. Does this data suggest that larger cars are safer? Now let's go back here. Another thing you can see here, this tells us lots of things. This tells us the average for each, some compact through full size. Full size, the larger cars are smaller. So, we're going to read each one of these. Yes, because the null hypothesis is rejected. Well, yes, it was rejected. The data suggests the mean deceleration for large cars is smaller. That seems like our answer. Because you can see smaller down here. But let's read them all. No, because the null hypothesis is not rejected. Oh, that's not right, because we rejected it. No, the null hypothesis is rejected, but the data suggests the mean deceleration for larger cars is larger, not smaller. Well, that doesn't fit our data, so it has to be A. Now, the thing about ANOVA is all an ANOVA really does is tell us, are the means the same or are they not? They're not going to pick out one or the other. You'll notice we weren't really able to tell us exactly about from our null. We knew we rejected it, the means are not the same, so each one is different. But to go any deeper, you're going to have to go back and look at other data. And ANOVA just tells you, do they match or do they not? For instance, if you were going to test 3 classrooms worth of students and you wanted to know, are they all getting the same test grades? You could test that. You could compare all their test values. Are they the same or are they not? And you could tell, well, this one's doing better, now looking at the averages, than the other since I rejected this. Now you look at why might that be true. So you can see an ANOVA really is a first step that tells you, okay, we have a difference. Then you have to do some exploration to why. The ANOVA isn't going to tell you why. It's just going to tell you one is different.